Hello, and welcome to this lesson on transition metals. In today's lesson, we will begin by having an overview of the transition metals, including their position on the periodic table, some of the common ones, and recognize that they exhibit different properties to Group 1 metals. We will then describe the differences between transition metals and Group 1 elements in terms of melting points, densities, strength, hardness, and reactivity with oxygen, water, and halogens. Finally, we'll exemplify the general properties, melting points, densities, strength, hardness, and reactivity with oxygen, water, and halogens of transition metals by reference to specific ones. We'll first locate transition metals on the periodic table, explore their unique properties, and then compare these properties with those of Group 1 elements. Transition metals are found in the middle block of the periodic table, spanning between groups 2 and 3. Notable examples include iron, copper, chromium, cobalt, and zinc. Understanding the contrast between transition metals and Group 1 elements is crucial. Let's explore this through various properties. Transition metals generally have high melting points. For example, chromium has a melting point of 1,907 degrees Celsius. A notable exception is mercury, which is liquid at room temperature. In contrast, Group 1 metals like sodium have much lower melting points. For example, sodium melts at just 98 degrees Celsius. Transition metals possess higher densities. Cobalt, for instance, has a density of 8.90 grams per centimeter cubed, much higher than that of any Group 1 metal. Group 1 elements, such as lithium and potassium, are known for their low densities, often allowing them to float on water. Transition metals are generally much stronger and harder than Group 1 metals. Iron, widely known for its strength, is often used in construction for this reason. On the other hand, Group 1 metals are quite soft. Many, like potassium, can be cut with a knife. Transition metals are less reactive compared to Group 1 metals. For example, copper does not react with oxygen at room temperature, whereas Group 1 metals like sodium rapidly oxidize when exposed to air. Similarly, Group 1 metals react vigorously with water. Sodium produces hydrogen gas and sodium hydroxide upon contact with water. Transition metals, however, do not react with water under normal conditions. Group 1 metals also react quickly with halogens to form ionic compounds, such as sodium chloride, which is table salt. Transition metals exhibit reactivity with halogens at higher temperatures, but not typically at room temperature. For example, iron reacts with chlorine gas when heated to produce iron, 3 chloride, but this reaction does not occur at room temperature. Now, let's use specific transition metals as examples can help solidify our understanding of their properties. Chromium, for example, has a melting point of 1,907 degrees Celsius. This very high melting point demonstrates the general trend in transition metals having high melting points. Cobalt has a density of 8.9 grams per centimeter cubed. This high density is a huge contrast to the low densities of Group 1 metals. Iron's strength and hardness means it is used in structures like bridges, and buildings showcases its strength and hardness. Copper's exceptional conductivity makes it vital in electrical wiring and electronics, highlighting another useful trait of transition metals. Despite their differences, transition metals and Group 1 metals do share some similarities. Both are good conductors of both electricity and heat. Both can be polished to a shiny finish, and both react with non-metals to form ionic compounds. Firstly, transition metals occupy the central block of the periodic table, situated between groups 2 and 3. These elements, including iron, copper, chromium, cobalt, and zinc, exhibit unique properties that distinguish them from Group 1 elements. Secondly, understanding the differences between transition metals and Group 1 elements is essential due to their contrasting properties. Transition metals have high melting points, higher densities, and greater strength and hardness compared to the softer, less dense Group 1 metals, which have lower melting points. Additionally, transition metals are less reactive with oxygen, water, and halogens than the highly reactive Group 1 elements. By looking at some specific examples of these transition metals such as chromium, cobalt, iron, and copper, we were able to illustrate their distinctive properties like high melting points, densities, strength, hardness, and conductivity. While transition metals differ significantly from Group 1 metals in these aspects, they share similarities such as good conductivity and the ability to form ionic compounds with nonmetals. In summary, this lesson has provided an overview of the unique properties of transition metals and how they differ from Group 1 elements.